Right, hello everybody. So I got a maintenance video here. I'm on the Helios Nanolab 600i, and I need to do some alignments to the FIB column. So I'm going to show you how to do these. My preferred sample for doing these, so you need something to use for centering and focusing on. What I like to use for this is a molybdenum grid. The reason being is that molybdenum is very hard and has a low sputtering yield, so it can take a lot of ion beam exposure without degradation. And then when you expose it, you get these nice nooks and crannies here, and these are great for focusing and stigmating on. So this is a pattern here that I just milled into the surface of the grid. It's just a series of like rings and lines and circles, and this is nice because provides features to look at. So I'm at 0 degrees here, basically at your centric, and I'm going to go ahead and tilt to 52 degrees. Before I do that, I'm going to make sure my beam shift is zeroed out for both of my beams, and then I'll tilt to 52 degrees. So whatever your typical SEM settings are, that's what you want to use here when you're doing this. In this case, we typically use 2 kilovolts, so I'm going to use that for doing the alignment. Okay, so then the center shifted a little, so I'm going to go ahead and center that, and there we go. All right, so now you need to be logged in under a service account or supervisor account in order to get access to the alignments. So you can go to alignments, and the one you want is 210 ion beam. We're already at 30 kV. That's what you want to start at. And then you click start. It's going to ask you which voltage. And you click next. And so the basic process with this is you start by making sure that the quad is zeroed out. Okay, so if you click on quad, you can then right click in the crosshair and then 0. You can then turn off the wobble. After that, you can use beam shift to center the feature. In this case, it's the center of this pattern. And then we need to align the aperture. So at 30 kilovolts, you want your quads all zeroed out, and you want to do all your image alignment or your alignment just by moving the aperture. Unfortunately, when you click aperture position, it's going to default to L1, and you want to actually use L2. Okay. So now the image is going in and out of focus. The current is obviously quite low right now, so the signal is not great, but you can right click on the crosshair. I like this on extra fine, and you're trying to now minimize the shifting with focusing. So let me throw this off here to make it more obvious. Okay, so you can see that's going left to right now. So I'm just going to adjust the crosshairs until this is zeroed out or stops moving. Okay, that looks reasonable right there. So the wobble is going to be easier to see when the currents are low. From here, you can mag in, use reduced area. You can focus using the focus knob. You can see what it's changing down here is L2. L1 has set values depending on your aperture size, so you don't want to mess with L1 at all. You shouldn't have to mess with L1 at all. That's done like with the source change, but L2 is your final lens. So you can focus. You can adjust your stigmators here. These look pretty good, but I'll throw that off there. You can see that. And now when you're adjusting the stigmators, if the image is shifting, it's not really doing this here. You can align the stigmators. Okay, so that's right over here where you have stig sign X and stig sign Y. So you can see this is really not moving because it's already been aligned. If you were seeing shifting as this was pulsating, you would want to align the crosshairs. You can see here with this one, it's also not really moving. Let me throw this to 0. Okay, so you can see hopefully now there's a little bit more movement there. I can quickly put this back by clicking on back, and there it goes back to where it was. Okay, so anyways, that's what you would adjust if you're getting shifting while you're stigmating. Let me turn this off so you can just select it, or actually you have to select something else. And then after doing all this, you might need to adjust the beam shift again, so you can go back to the same mag you used for the SEM image, which is in this case 2500, and then adjust your beam shift crosshairs. And once that's good, you click save and you're good to go. So let's go to the next current up. And again, start by aligning the shift. So as far as the sample, like the thermo engineers like to use the silicon crosses. I don't like to use those personally because they just wear out too fast. Okay, the molybdenum it can take more of a beating, and of course you have more stuff to focus on versus just those, linear crosses. Again, the quad should already be zeroed out for all of these. I'm just going to verify that, and then do the same thing, activate aperture position, and then L2. And then sometimes magging out makes this easier to see. So now, unfortunately, with this, the scan rotation for the FIB is 0 right now. If you adjust the vertical crosshair, meaning you're dragging left to right, that adjusts up and down movement. And if you adjust the horizontal, meaning you drag up and down, that adjusts left to right movement. Okay. All right. That looks pretty good though. Mag in. Turn on reduced area. I'm going to turn on, the large image window. You can't see it here, but I'm looking at it. It's just easier for me to see. Okay, looks reasonable. Obviously, you don't have to be in supervisor mode to focus and stig when you're adjusting those. You can do those directly. All right, save. I'm going to skip over the 30 because this is actually blown out and it's too large from overuse. So I'm going to go straight to the 50 and do the same thing. Okay, quad is zeroed. Oops, sorry. Aperture position. So the aperture position tends to be more sensitive at the lower currents because the apertures are smaller, and so any misalignment is going to be more evident. Unfortunately, you have to, to directly adjust the aperture alignment, you'd have to be logged in as a service for that. Let's mag out a little bit here. Yeah, maybe a little bit of side-to-side movement, not a whole lot, but okay, looks decent. As the current goes up, you don't need to rely on reduced area quite as much because you've got more signal to noise, but that looks good. Okay, so just quickly, again, I did these earlier. I don't know if I mentioned that, so I'm just going to quickly align the beam shift for these. This alignment array has taken a beating. I've used this several times, so probably would be good to mill a fresh one, but don't need to worry about that for now. So as you get higher in the current, the process is the same. The issue though is it becomes harder to see the wobble. I've been able to do this effectively up to the second highest FIB current, meaning the 50 nanoamps. Once you get to the 65 nanoamp aperture, that one is trickier to align. That's best, in my opinion, left to the service technician to do that. He has a way to actually check the centering mechanically just by seeing like where the limits of the aperture edge are, and then using that to center the aperture. Okay, I wouldn't recommend you try and adjust that one yourself. Maybe someday he'll show me how he does that. But until then, I'll leave that to him. I generally don't use the 65 nanoamp aperture on this system anyway. I'll top it out at around the 50 anyways. Because you're talking about, not an inconsequential difference, but a noticeable one, but still fairly minor. Okay, so once you get above 15 nanoamps, your optimal focus is a little bit trickier, okay? So because your aperture is bigger here, you've got a lot more contributions from aberrations. What you need to do now, if you want to dial in the focus, so I already did this, so I'm not going to mess with it here, but what you need to do actually, you don't want to rely on the image for the optimal focus. What you need to do is actually burn holes into something. So this is actually where like a silicon wafer works better. If you have like a nice flat surface and it's a single crystal or something that's amorphous. So you actually need to burn holes, adjust the focus, burn a hole, adjust the focus till you see like the tightest hole, okay? So, you know, just to give you an idea, right? If I pause this here, I can go to scan, spot, and then I'm gonna put the marker over here and then unblank. I'm just gonna let this go for like a few seconds and then blank. And there's the spot, okay? So anyways, I can tell this already looks good. So I'm not gonna adjust it, but yeah, that's what you need to do. Then you'd have to tilt back to 0, of course, as well. So this is a little bit more involved to optimize the focus at these higher currents. So this has already been done, so I'm not gonna mess with it, but that's the basic idea. You'd have to make a change to L2, burn a hole, you know, make a change, burn a hole, and then figure out where your tightest hole is, and then put L2 for that value. You can full frame, there we go. You can still adjust, yes, you can see that's a good, I mean, this isn't an optimal sample for this. This is, you know, molybdenum, but this actually looks good. So you can still adjust the shift and the stigmation center and the stigmators as well. This actually look pretty good here. You can just mag in here and see, right? So that's the stig off. Okay, that looks decent there. But yeah, it's a little counterintuitive, but your image might be a little bit out of focus at these higher currents. Again, if you're trying to get minimum burn mark, okay? So again, up to the 50, you can use the aperture position to dial this in. I wouldn't recommend you do it at the 65 nanoamps setting. So again, I can stop this here, go to spot, I'll put it right there on blank, blank. Okay, and there we go. So yeah, this should be a little bit bigger than the last one, so on and so forth. Oops, I don't want spot, I want full frame. Okay, yep, there we go. Okay, actually looks fairly similar to the 30, which is good. Okay, then we'll save this, and then we'll go to 65. And do the same thing, okay? So with the fifth, like I find that with these, again, I wouldn't do this with the 65, but with these lower, below 65 for these higher currents, usually if you mag out, it becomes easier to see the image wobble, okay? So I'll demonstrate this with the 50, just so you know I'm not lying to you. Okay, so we'll use this here, and then we'll turn on aperture position and wobble, okay? So let me throw this off here so you can see. Okay, so that actually made it better. Let me put it back to 0. Okay, see the difference now? That's going left side to side. Okay, so again, we're trying to minimize that. Again, I find up to the 50 that you can do this and it works fine. Okay, looks like the up and down movement is negligible, so we'll go ahead and leave that alone. sorry. And then if I pause the image, you can see I'm reading nominally 50 nanoamps, okay? So as long as this is nominally 50, you know, with the wobble removed, then everything's fine. Okay, then we can mag back in, and looks like we're still centered at the appropriate mag. All right, and we'll click save. And now there's always going to be a little hysteresis, so even though we've aligned everything for these different apertures, like if I go back to say the 300 picoamps here, it may not go quite back to the same position. That's normal, unfortunately, although it's actually, you know, gone back pretty accurately, believe it or not. Okay, so I'm going to stop this. And so now this is at 30 kilovolts. So now the question is, what do we have to do at the lower voltages? So it's a little bit complicated, okay, but we can't just go straight into doing the alignment at the lower voltages. What we have to do is actually apply the aperture positions that we've established at 30 kilovolts for the corresponding apertures at all the other voltages, okay? So that's the idea, is you align the apertures at 30, and then from there, you do all of your alignments at the lower kVs, not by moving the apertures, but by adjusting the quad, okay? So as far as applying the aperture positions to the other voltages, we can do that. It's a little bit of a process here, but I'll show you how this works. So let me just click save and then finish. And then let me tilt back to 0 here, because I think what's gonna happen, I'm gonna turn the beams off, because I think what happens, we have to stop and then we have to stop the server and then restart it, or stop the server, do the thing we need to do to apply the currents or the apertures, and then start the server again. Okay, so I'm gonna turn off the beam, I'm gonna turn off the SEM, and I think it'll turn the source off automatically. I'm gonna go ahead and tilt back to 0 here. I think it will remember, it may have us home the stage after we reboot the server, but I'll just leave it here for now anyways. Okay, so we're gonna stop the UI, so we can click it here, or we can just close it. So we'll just click stop UI. Okay, and then we need to open the server window, and the over here along the left side here, we need to find the so I believe it is this, yes, this guy. Okay, so right, it's aperture alignment, so table. So we have to stop the server, okay? It's right, it's telling us. So we're gonna click stop. That's gonna sleep the source automatically, which is why I didn't bother to do that. Okay, and then we're gonna open this up, and then you're going to click transfer 30 keV values, okay? So I think, right, there's only one. Yes, we want to do just the FIB. You're going to click transfer 30 keV values. It's going to ask, are you sure you want to transfer them to all voltages? And you click OK. And then it's done. And then you click exit, okay? So now we can start the server back up again. And once we have this booted back up and the UI back up and the source back up, I will explain to you what we have to do as far as the low kV alignments. So with the low kV alignments, there tends to be a lot, or with the low kV settings, there tends to be a lot more hysteresis. You do have direct control of the quad, I believe at 8 kV or less. You don't have it at 16 kilovolts, so if you use 16 kilovolts, you don't have direct control of the quad, unfortunately. But you do at 8 or less. So, you know, we can go through, I mean, I'll go through how to do the alignment, but the nice thing is that You really don't have to do the alignment because you have direct control of the quad and the beam shift and the focus and the stig for 8 keV and less. So again, you can just kind of get it in the ballpark, and then when you're actually using the microscope, you know, when you're about to do milling at 8 kilovolts, you can manually do the alignment, which is probably going to be necessary anyway. So that's why I don't usually kill myself doing the low kV settings, because they usually need a lot of tweaking anyway when you go to use them in practice. Put this over here, sorry. Okay, so now we need to log back in. Again, ask your FSE for this information. Let's see if it shut off the source for the FIB. I believe it probably did. Oh, it didn't. Okay, score. All right, didn't set the stage back either, so we're good to go. All right, we just have to turn on the beams. Okay, and we're going to tilt back to 52 degrees, of course. Okay, looks reasonable. Mag in here. Okay, I'm going to leave 2500. Okay, and then just like we did before, you're going to go to alignments, find 210 ion beam, start, and now you have to pick one of the lower voltages. So the process is identical for any of these settings. It's going to be easier to do the alignment the higher the voltage is, because you have better resolution. At 2 kV, it gets much more challenging to do the alignments because the image is just blurrier. And I definitely noticed too, as you go down in voltage, like the effect of the vacuum becomes more of an issue. You can see like we're in the high -7 range, so this is good. So we shouldn't have an effect, but I definitely noticed like down at 2 kV, if your chamber vacuum is not at least in like the low -6 range, this can also get blurry just by virtue of scattering from the pore vacuum. Okay, so for the sake of argument here, now again, the other thing I want to point out here, if we adjust direct alignments, so you can see you have direct control of quad if you're at 8 kilovolts or less, okay, but not at 16. So keep that in mind. And same thing with the stigmator centering as well. Okay, so let's just we'll do a couple of these at 16 and then a couple at a lower voltage just so you can see how this works. So we'll select 16 and then next. And then, again, I like to start low and go high here. Now it's, depending on what you do with the system, right, you may not really have application for these higher currents at the lower voltages anyway. A lot of times those are used more for like, finishing, which you're doing at low current. So it may not be necessary to like align all these. I'm gonna go ahead and we'll leave it right there at the 0.15 nanoamps, which is, again, that corresponds to the 300 picoamps at 30 kilovolts. Okay, so you can see like at 16 kilovolts, we still have a fairly good amount of detail. So now, center with the beam shift. And now you're gonna activate quad. And now you do want to minimize the shifting by adjusting the quad, okay? So again, use extra fine. Okay, see I made it worse. Now with the quad, the up and down pulling does adjust the up and down motion, okay? And pulling left to right does adjust the left to right motion. So that's actually different than, so that's worse. Okay, that's worse. If you stare at this long enough, you'll just drive yourself crazy. That looks good there. Okay. Now when you adjust the quad, you may need to readjust the beam. Again, you may need to readjust the beam shift. We can check the stigmation centering. That looks good. That looks good. And then from here, it's just a matter, like before, of focusing and stigmating if you need to. So the stigmation looks reasonable. Again, you have direct control of this when you use the microscope anyways, regardless of the setting you're at. Although I find, again, as the voltage goes down, that the settings are less reproducible. All right, then save. So we did mess with aperture position. We transferred that from 30 kilovolts. All right, so let's go to the 50, and we'll do that one, and then we'll do one at like 5 kilovolts, so you can appreciate the difference. Okay, align the quad. That looks reasonable. Okay, let's adjust the up and down. That's worse, clearly. Okay, probably overshot it slightly. That looks okay. Right, and then adjust beam shift. Stigmation center looks good. Okay, we can turn on reduced area here. Okay, looks reasonable. All right. All right, again, we can do this for, whatever currents we want. Click save, click finish. It's gonna go back up to 30. I'm gonna click start, and we'll go down to 5 and do the same thing here. So this is a very low current, 16 picoamps. So let's do this one so you can see how challenging this gets. So we can still see some detail here, which is good. Right, so you can see now the beam shift is more sensitive as the voltage goes down. Okay, let's see if we can boost the contrast a little bit. So we can. Okay, we can try reduced area here. All right, so let's see if we can get this to jump. Okay, hopefully you can see like that's moving up and down. Let's see how it looks without this on. Yeah, you can see it. It's noisy, but you can definitely see it. Okay, so. Again, you have direct control of this when you're actually using the tool. You don't have to be in supervisor mode. Okay, wobbles off. And you can see even at 5 kilovolts with this column, you can see really a lot. So now it looks like the stigmation centering's off here. So let's go ahead and adjust that. Okay, yeah, so this is definitely off. So we'll go ahead and minimize the movement here. Oh, that's getting worse. Okay, that looks good. We'll do the same thing for cosine. And it's just analogously referred to as just X and Y. Okay, there we go. You do also, as I mentioned, you do have direct control of the stigmation center as well when you're doing, yeah, so the stigmation is a little bit off here. Okay, and then if we go back and forth, that looks good right there. Okay. And now again, we can mag out here, and last thing is if we want to tweak the beam shift slightly after doing that, we can. All right, very good. Let's do one more. Let's do I normally don't use lower than 16 picoamps at 5 kilovolts. I have used the 48, so we'll go ahead and use that, or align that, I should say. Okay, align the quad. Okay, so you can see we have more current now, so that's more obvious here that this is out of alignment. Okay, that's worse. Okay, that looks decent. All right, and we'll turn on. Okay, we got some astigmatism, so let's see here. All right, so it looks like the stigmation centering is already good for this guy, or this aperture setting, I should say. Because when I'm adjusting the stigmators, it's not going all crazy on me. Okay, that looks good. All right. Mag out here to 2500 indicated, and we can move this to the center. Okay. I forgot the other thing is we can just, you know, we don't have to click finish. We can click previous and then change the voltage. Let's do one at 2 kilovolts just so you can appreciate how tricky this is. All right, let me pause it. I'll click save again because I'm just OCD like that. Go to previous, 2 kilovolts, and let's align 27 and the 8.9, which are the ones I typically use on this. Okay, so you can see we lost signal, but we can still see the switch to extra fine. Does, fortunately, it defaults that to normal when you switch voltages. Okay, so this is going to be trickier to see here. So let's see if we can. Let's see if we can boost the contrast just a little. But yes, this is the challenge with these. So sometimes dropping the wobble can help a little bit here. Let me see if I throw this off, if I can make, okay, so that's a little more obvious there. It's going up and down, okay? So yeah, it actually wasn't off by much, believe it or not. Okay, so now it's going up and down still because I overshot it. All right, that looks decent right there. I find this is easier like on a lamella on a grid, so just have to remember, again, you have access to direct alignments when you're doing this in you know, real life, so to speak. All right, turn on reduced area. Okay, looks like now again you're definitely losing detail as you're going down in voltage here. So now I don't know what we're going to be able to see here. This is where having these nooks and crannies really comes into play. So it actually looks like, let me bump this up one more click. Okay. Okay, so hopefully you can see that, where that kind of just dials right in. Yep, right about there. So let me boost this up here so you can, yeah, so this actually looks pretty good, believe it or not, at 2 kilovolts, right? That's about as good as I would expect. Okay, let me stop that, sorry. All right, beam shift. I definitely noticed at the lower voltages, particularly 2, that the beam shift has a lot of hysteresis, so I definitely wouldn't count on that to be like well aligned when you switch to that setting. All right, And then let's see if we can do this last one here. This one's gonna be really challenging. Okay, so it looks like it's going, again, I know it's tough to see. Yeah, see, I've already got the contrast boosted all the way up. It does look like it's moving up and down though, okay? Let me see if I can't, okay, that's worse, right? I hope you can see that, but it is going up and down here. Okay, probably overshot it slightly. Okay, that looks as good as I can get it with this sample. So I'm gonna leave it there for now. Oops, turn off wobble. Okay. So we should see more detail as we drop the current down. It looks like, yes, the stigmation is a little off. This again is going to get really tricky to do here because the current is this low and the voltage is low, but that looks about right there. We weren't seeing any movement with the stig, so we'll leave that alone. All right, so let me bump up the dwell time here. Yeah, so that looks really good as far as 8.9 picoamps at 2 kilovolts is concerned. Again, I can't boost the contrast anymore, but hopefully you can see that, okay? Yeah, it always amazed me how good the low kilovolt performance on this, although I've heard that some of the newer tools, it's even better. All right, so that looks good. All right, so we'll go ahead and beam shift to the center. All right, just for fun here, let's take a photo. All right, that looks about as good as I would expect for 8.9 picoamps and 2 kV. All right, very good. Click save, click finish. It's going to go back to whatever voltage we started at before, okay? Although again, don't be surprised now if we go back to 30, this may not be quite perfectly centered. Again, we did tilt back to 0 and then tilt back and then adjust it. So if we unpause this, might not be perfectly aligned, but that's okay. Again, it's within the, limits of, okay, so that's actually pretty good. Yeah, so it's still centered really well. All right, so there you go. That's your crash course in doing FIB column alignment. That's the Sidewinder HT FIB column alignment. So now with the newer columns, I'm not sure, I haven't used one of those. I hope to someday before I die. But I just wanted to share that with you on this rainy Friday evening. So take care, everybody. Peace out, my EM aficionados.